Hey everyone, good morning. It's a real pleasure to be here. Thanks, Matt. As you mentioned, my name's Mitch. I'm a Director of Engineering here at Datadog. I'm actually based out of the New York office and I work in infrastructure. I'm really excited to be here today and talk about some of the lessons from building Datadog's latest data center right here in Sydney. Where I wanted to start my talk is going a bit back in time and seeing where Datadog started. So Datadog has always been a global software as a service company, but initially when we started, all our infrastructure was hosted in one region. It's what we call US 1, and it was based out of AWS's US East 1 region. This got us through our first 8 years of history. So it was initially pre-containers, so this was a lot of VMs and chef scripts, so forth, but over the years we've modernized it. It's now 100% Kubernetes. As the company was growing, this data center just kept getting bigger and bigger, and we quickly realized that we not only had to scale this data center up, but also expand out to meet our customers in other regions. This was particularly important from like a regulatory point of view and meeting customers' expectations around privacy. So fast forward to 2018, we launched our second data center, EU1, based out of Frankfurt. This was a really exciting opportunity for us as a company. It was the first opportunity we had to rebuild an entire Datadog stack from scratch, and we used it as a modernization opportunity. So this data center was 100% Kubernetes, and it was also on GCP, which was a new cloud provider for us, and that gave us plenty of learning opportunities and a deeper understanding of our customers also on GCP. Moving to 2021 and 2022, these were busy years for us. We launched US 3, US 5, and a Fed region. This also covered Azure, so we're now hitting all three major cloud providers. And then fast forward to 2023, finally we launched our first region in APAC. This is AP1 out of Tokyo. This took about a year of work on the infrastructure side, building it out. And then fast forwarding all the way to where we are today, we're very excited to launch the AP2 region right here out of AWS's Sydney region. And this data center is all part of Datadog's long history of supporting Australian and New Zealand businesses. So some history of Datadog in the region. We opened our Sydney office in 2016, and then we also recently opened a second office in Melbourne. We now have over 1,000 customers in Australia and New Zealand, and we knew that continued investment in the region was very important, so we're really excited to launch this data center. This visualization gives a bit of an overview of Datadog's global data center footprint. However, from my perspective as an infrastructure operator, this is looking a little bit crowded. There's a lot of data centers here, there's a lot of operations we need to do, a lot of software to keep up to date, and as we continue to expand over the years, it started to challenge some of our assumptions about how we run, operate, and upgrade our software. Today I want to talk about some of those problems and some of the solutions we've recently put in place to try and manage this global fleet of data centers. Before I go into those details, I wanted to briefly introduce myself and why I'm talking. So as I mentioned, my name is Mitch Ward. I'm an engineering director. I'm based out of the New York office. I've been working at Datadog for over 4 years now. I actually started as an engineer. I was leading a small team building a database, which was a lot of fun. It was a really hands-on role. And then over the years, I had the privilege to grow with the company and now leading a relatively large org that covers all things databases, streams like Kafka, workflow execution, task execution, and also coordination primitives like leader election, sharding, and locking. Part of why I'm particularly honored to be here today, I actually grew up in Sydney. I've been in New York for a little over 8 years, but back in 2017, I actually worked just down the road at Google as an SRE. And like Matt, I'm also a big sailor. I really like to sail. I sailed in Sydney and I'm now sailing in New York, and definitely sailing in the Sydney bays was a lot more relaxing than the Hudson River, but I make it work. Back on topic, I wanted to talk about how we focused on solving some of these problems this year and introduce an internal program that we called Project New. So this was a large-scale effort involving many teams that was really focused on how do we make data center bootstrapping and management simpler internally. We broke this program into 4 focus areas, and the foundation was, of course, data center bootstrapping. So here the question is, how can we make new data center build-outs easy for Datadog's infrastructure teams? And the goal here is to be organized and repeatable, and not like a heroic exercise every time where we have to rediscover how everything's built. Once it's bootstrapped, software delivery, of course, is very important. So here, we're trying to look at how do we safely keep the whole fleet, this global fleet of data centers up to date and making sure that every region is getting all the new Datadog features at the same time. The third pillar here is operations. So like any company, there's plenty of manual operations we have to do as infrastructure operators. And as the number of data centers keeps growing, how do we scale this in a reasonable manner? And the pinnacle here, and arguably the most important, is costs. So as an infrastructure team, we look at Datadog's internal costs, and we're making sure that we make our infrastructure cost efficient and over different cloud providers and different sort of orders of magnitude in terms of throughput and load. So yeah, I want to cover these 4 problems we faced and some of the solutions we put in place. And I'll start with the first one, which is data center bootstrapping. So from my perspective, data center bootstrapping is really a sequencing problem. Every time we bootstrap a new data center, we have to deploy a whole new Datadog. And I don't know if anyone can relate to this service map diagram here, but Datadog is this is just a fragment, but Datadog is a web of hundreds of microservices. This is backing our dozens of products, but then also behind the scenes, we have many scheduled jobs in terms of like alerts, synthetic tests. We have crawlers that are scraping API endpoints, there's indexes of logs, there's all these different services working. And beyond just the services, there's layers of dependencies. If we're not intentional here, when we bootstrap a data center, some service just will not deploy unless its dependencies are available. Third point here is constant change. So as Datadog, as a growing and fast-moving company, we're always launching new products, new features, and what that means is we can't take sort of a cookbook from launching AP1 and just apply it to AP2 because our internal infrastructure has evolved so much over the years. And then finally, there's dozens of teams involved. So the culture at Datadog is you build it, you own it. So when we bootstrap a new data center, there's lots of people involved in deploying their infrastructure. Put these 4 points together, and basically it equals a lot of time and effort without any structured organization. So we knew there was stuff we needed to do here. So how do we solve this? So the first, I guess, potentially obvious thing is around technical program management. So a large initiative like this definitely needs organization, program management, and planning. At Datadog, we're really fortunate to have a strong TPM team, and working with TPMs has been invaluable from my perspective to help get this delivered on time. Of course, they're communicating, they're setting timelines, and they're tracking progress towards our goals. On the right here, we see this is a spreadsheet, it's a collapse view, there's many steps under, but all the waves involved in bootstrapping our new data center. And the TPMs are also really helpful in terms of categorizing these steps. Of course, once we launch, they also run retrospectives and iterate such that our next data centers go faster, of which there's more we plan to launch. So in terms of those waves of deployments, how we categorize that is through dependency mapping. Our production environment is constantly changing, so it's very hard to draw on a whiteboard what an architecture diagram will look like. New products are integrating new features and connecting between one another. Of course, we dog food Datadog's internal developer portal, and we have an internal API framework which exports the necessary metadata to create these service maps. This is really helpful to organize those bootstrap waves and then get our deployments done. However, when I talk about waves, we still know that if we were to deploy these services sequentially, like from the very bottom of the stack to the top, it would just take far too long. And so here we have that observation that if we have less waves of deployment, it'll take less time and would prefer to be doing parallel deployments. At Datadog, many products can depend on other products. You know, the interconnected data is definitely a feature. And so we want to be sort of intentional about how we can deploy this quickly. The great news is that we're 100% Kubernetes in our infrastructure, and Kubernetes has a number of features that allows us to sort of deploy things in parallel, tolerate that dependencies aren't quite ready, you know, the data center is partially broken, but then as dependencies come up, it all reconciles and self-heals together. How do we know that it's healing? Well, we use internal synthetic tests that are testing those end-to-end sort of critical user journeys of the Datadog product. And then as the bootstrap goes on, we sort of see a graph going up in terms of tests that were failing and are now succeeding. Drilling in specifically to some of the Kubernetes primitives that we use, here the readiness probes are really key. So in Kubernetes, on any pod, you can have a liveness probe and a readiness probe. The liveness probe is just testing basic functionality. Like, is this pod not in a deadlock? Does it respond to a simple API call? But then the readiness probe is validating that all the critical dependencies are healthy, and then when they are, move it into our service discovery infrastructure. Great, so now that we've launched our bootstraps, this new data center, we know that even post-launch, like, availability is critical to our customers, and we do need to continuously deliver software and deliver it safely in terms of new features, upgrades, security patches, etc. So how do we approach software delivery? Well, internally at Datadog, we have our own software delivery platform. Back before 2020, we actually used Spinnaker, but as our infrastructure size was growing in terms of number of deployments and number of data centers, we decided to move to our own stack, which is based on Temporal, an open source workflow orchestration system, and also Helm in terms of the files that we apply to our Kubernetes clusters. Of course, it integrates into Datadog's CI/CD visibility, the internal developer portal, so forth. And on the right here is a real diagram, a real screenshot of all the deployments we've done over a week. We're largely succeeding. This is kind of US business hours primarily. And we see some failed workflows, which is often intentional, be it a monitor gate failed or for some reason we needed to roll back. The key thing when we're thinking about these deployments internally is we had a bit of a cultural shift in terms of thinking about deploying to an individual data center to always deploying to the fleet. So we're never thinking about one data center or another. We just think of the global footprint of Datadog, and this required changes to our automation, tooling, and processes to make sure everything goes everywhere in a safe manner. One of the key ways we achieve that is through feature flags and gating launches. So internally, again, we have a feature flag platform. On the right is a screenshot of a real rollout of a feature. This was for DBM. And then through this UI, we get really excellent visibility and uniformity in terms of how we roll out across. So if you step through on the right there, it says that we're going to this feature, we're going to enable it to 10% of customers in a certain region, wait 20 minutes, check a monitor gate, make sure that user journey is still working, and then progressively roll out through the steps in the regions. This baked into this feature flag platform, we've got safety features, so like the schedules, the monitor gates, and we can also very quickly roll back if something does go wrong. So feature flags are used for launches, but of course we still need to deliver software containers in terms of upgrades across the fleet. As our fleet kept growing, we started seeing deployment problems at scale. The first one was a little bit of an own goal, where in our software deployment infrastructure, we're very unopinionated about how software is deployed globally. So teams were curating their own workflows, and when we added another data center, we had to go reach out to everyone and say, please add this data center to your workflow. This was very manual and created a lot of cognitive overhead. Also, just the observation that more data centers is slower deployment. If you're going sequentially and you have a lot of waiting time, some of our deployments were taking over weeks, and we'd prefer to be continuously delivering and shipping features quickly. Forward. And finally, just noting that as we have more workflow steps, we're conservative, and some of our retry policies weren't as aggressive as maybe we should have been, and that means that occasionally if a workflow had 1,000 steps, it was just failing. We needed all those steps to fail, and we're seeing a lot of failures in terms of that end-to-end journey. So how we address that is we create an internal deployment spec. We call this deploy.yaml, and this was a simplifying abstraction where we're building in years of lessons learned of how we like to deploy, and we created this declarative and intent-driven file. So teams were no longer handcrafting workflows in a domain-specific language. Instead, I know it's small on the screen, but here's an example service called Thunderdome, and what we're saying here is we want to deploy it to the prod site. So we're not listing any data centers here anymore. We're just saying, please deploy it to production. And here it's configured to deploy to 3 Kubernetes clusters per DC. And users no longer have to worry about where these things are rolling out. Of course, there are per DC differences, and how we manage that is with Helm values in a templated form that are injected at deploy time, abstracting away some of that complexity. So by taking control of the deployment workflows as an infrastructure team, this has enabled standardization for us across the company. So first of all, from a safety point of view, we never ever deploy globally all at once, and we have ultra-fast rollbacks if things go wrong. From a scale point of view, all the data centers are always included, and we have careful sequencing and parallelism to make sure that features are deployed or software is deployed in a timely manner. And lastly, from like a developer experience and efficiency point of view, teams don't have to worry about handcrafting workflows. They can just focus on their product, and us in the infra org handles this for them. So here's a real example. This was a deployment of some production clusters to the AP2 data center. This was after around 2 hours, this was after many validating steps, but then we deployed it across all of AP2 in about 2 hours. Here, I know there's a lot on the screen, but it was a Fibonacci-style ramp-up where initially we deployed to 2 Postgres clusters, then 3 Postgres clusters, then 5 in parallel, 8, etc., where along each step, we have monitor gates and sleep and validating that things are looking good. Great, so now we've got our software delivering continuously, but we also have to be mindful of operations. So like any company, even though we've got some of this internal tooling, manual operations still exist for many, many things. So for example, database operations, topic creations in Kafka, access management, or resharding some of our internal systems. As infrastructure operators, if we have 1, 2, maybe 3 data centers, this is tolerable, but as the fleet has kept growing, this has just been a recipe for burnout if we're asking people to do all these manual steps everywhere. So of course, the solution here is fleet-wide automations. So we're building an internal automation platform, which is less error-prone, and it has built-in safety checks, so we know that we're doing the right actions. And then through that, we've had a reusable ecosystems where teams build off one another to make their workflows. What does this look like internally? So at Datadog, we also have 2 control plane data centers. It's this blue-green style deployment where one is an active and one is a failover, so we can always be confident that we can do the operations we need. The site data centers, these are the commercial offerings of Datadog that you see on the right of the screen, they're fully isolated. Each one operates independently, but we have an auditable, secure action bus which can deliver workflow intents from the control plane to each site. This is end-to-end secure, so users' actions are signed like with a YubiKey where there's end-to-end personal identity verification, and we can be confident that these actions can be distributed safely. What does the automation platform look like? Well, we call it Atlas internally, and this is also based on temporal. So it's the same origins as our software delivery automation, and it's a really excellent reusable ecosystem of workflows. So every team has their own domain of workflows that by default are restricted, but then they can opt in for other teams to call their workflows, and we've built these really rich ecosystems. Of course, again, there's safety checks, there's verifications, and there's prompts, so this is less error-prone. We've done a few public talks on this, so if you're curious a bit more about Atlas, come find me in the hallway and I can share some more details. But now that our ops are managed, I also want to talk about how we approach cost efficiency of this global fleet. So like any company, this is really important for us internally in the infrastructure org. We care that our infrastructure is efficient and meeting Datadog's business goals. To do this, we heavily dogfood CCM, we action its recommendations, and you'll be hearing more about CCM today. So instead, I also wanted to take a step back and sort of briefly touch on the business model of like a software as a service company. So for us, it's all about elasticity, and as our usage grows, as our customers, people in the room, are sending more metrics, logs, and traces, we want our infrastructure footprint to grow proportionally. We want our cloud spend to grow with the usage. Now, by depending on the public cloud, this makes this very achievable. Datadog uses AWS, Azure, and GCP, and essentially through Kubernetes, vertical and horizontal order scaling, we can meet these cost efficiency goals. How do we know if we're doing a good job? Well, internally in the infra teams, we really focus on unit cost metrics. So we extract the cost and throughput data from CCM and metrics, and then we can compute, like for example, like number of dollars per million queries. And then so it doesn't matter if our customers are sending us 1 million, 10 million, a billion queries. If we can see this metric, we know that the unit cost is within a bounds, then we know we're doing a good job here. But the last thing I want to touch on is that scaling isn't always linear. So we can auto-scale, but on the extreme ends of like a smallest data center to the largest data center, sometimes you want to make architectural changes. So in this example, this toy example, we've got 2 APIs that are small features, let's say, of Datadog, and they're sharing a Postgres cluster where they each have their own table of the data that they need to serve their API. Let's say API 2 grows. As it's growing, maybe the database is getting a bit loaded. So here we could split them out. Instead of having a multi-tenant Postgres cluster, we now have 2 isolated single-tenant clusters. Maybe the product keeps growing and gets even more load. It might make sense to put a request cache in front of the API just to offload the downstream dependencies. So the observation here is we're not just scaling, we're also changing the system architecture. So holistically, how Datadog scales is we use Kubernetes. This is like the primary one is Kubernetes horizontal and vertical auto scaling. We have modular multi-tenancy. So depending on the use case and the location, we might make things multi-tenant or single-tenant. And then these t-shirt size architectures. What do I mean by t-shirt sizes? Well, it was essentially those 3 illustrations. So whether a data center is small, medium, or large, we will bake configurations into our Helm chart that changes how the application is deployed to the region. Great, well, thank you so much for listening to those 4 problem areas. I hope it showed some of the challenges that we face scaling Datadog to a global data center footprint. And to summarize this project new and some of the main things that we took away from it is number 1, of course, is bootstrapping is complex. There's a lot of moving pieces to building something from scratch, and that project plans and repetition have really helped make this routine. Specifically with Kubernetes, there's been some technical solutions that we've been able to shorten our dependency chains, which has been great to move faster. Once it's deployed, global feature parity is like a key business goals. We achieve this using feature flags, and we have a feature flag platform, and that has safety built in terms of monitors, quick rollbacks, and we always want our rollouts to ramp up gradually. We're never deploying globally all at once. We never want to cause some gigantic global outage. And finally, of course, manual ops doesn't scale. Industry's been talking about this for decades, but it's really important to invest in a reusable automation platform. And then from a cost efficiency point of view, auto scaling and t-shirt sizing is our approach to how we tackle that. And then with all this combined, that's the reason we're here, is we're really excited that we're launching new data centers, that we have the Aussie DC launch recently. And yeah, thank you so much.